All right, so this is something all companies should do. So I think we can all agree that, if you have a monitor that's like, I don't know, 12 inches and you get, I don't know, so you're on like a laptop and then you get one that's 16 inches, that seems like a way bigger difference than when you're on like a 27-inch monitor and you go to a 31-inch monitor. And there's still a difference, but it's a much less small difference. And that's because humans tend to perceive things in ratios. So for the first one, the ratio, new over old, that's 16 over 12, which is 4/3, which is 1.3 repeating. That's 1 1/3 times as big, but 27 to 31. I'm gonna be honest, I don't really feel like doing that in my head. If we did, like 28 to 32, that'd be 32 over 28, which equals 16 over 14, which equals 8 over 7, which is 1 1/7. And that's a way smaller difference than 1 1/3. That's 3 over 21 versus like 7 over 21. And I came here to talk about this because this also happens with, technically we're measuring area here, so there's a bit of a disparity. Like if you had a monitor that was at brightness 99 and then it went to brightness 100, you're probably not even going to be able to notice a difference. But if we went from brightness 0 to brightness 1, bad example here mathematically, brightness 1 to brightness 2, that's a way bigger difference. So the overall formula here is what we have initially, x initially, plus delta x, like the change in something, our initial value plus the change, that's the new, and then divided by the old, that's xi. To simplify, that is 1 plus delta x over xi. Now, if we went in, I don't know, let's say steps of 1. Let's say we're going in steps of 1. Then delta x would be 1, and this, we're turning this into a function or whatever. That's 1 plus 1 over x. That's how we perceive the difference in things. So if I pull up Desmos here, why is that capital? What the hell? Y'all can see that gets smaller over time, like between 1 and 2. That's a slightly less pronounced difference, but given an initial value of x, we get x plus 1 over x, which is equal to 1 plus 1 over x. So the difference between like just take off this 1, dude. What the hell? So 1 and 2, that's a huge gap, right? But 2 and 3, it's a little smaller. 4, it's a little smaller. 5, it's a little smaller. But this is the difference, right? This is like the difference that we measure something. Like, this is how our like perceived difference in stuff changes. A change in something given size, I don't know, let's call our perceived version y, and then x is the actual thing. My face cam is covering that. So the perceived difference is y, and then that's 1 over x. We could say that's the difference in y over the difference of x, right? Like how much we perceive a difference based on how much something actually changes is 1 over x. Now, if we just want to get a map that shows how much we'll see something over time, like how much this changes over time, like the area under this, we can just integrate that, and then we'll get the natural log of x. So this is like how we perceive stuff. So this is about where that fits. Nah, I can't do it. If my monitor brightness starts at 1, I'm not perceiving any difference. Goes to 2. Yeah, there's some difference. We go to 3. There's less of a difference between 3 and 2 than 4, and then it gets so on. It gets smaller and smaller and smaller and smaller and smaller. And then eventually we're going to have to put in an astronomically large amount of numbers in order to actually like perceive a difference. And that's why that happens, is we literally perceive something as the ratio of new over old. So equals x plus 1, or no, 1 plus 1 over x. And then we have int let's turn that off. We have 0 to x p t dt. Where's the graph for this? What the hell? Hold on. Yeah, I feel like the difference isn't even 1 plus 1 over x. It's just... the difference just is 1 over x. So, yeah. Natural log of x is that. So, what tech companies should do is they should do things with exponents, right? Like if my monitor brightness, if stage 1, I don't know, let's yeah, that's pretty clean. So if monitor brightness went like this, where we put in a value and it keeps going up exponentially, doubling every single time, like the brightness doubles every single time. Like it gets very, very big. If we have like 256 brightness levels, because that's what 8-bit color has for every single thingy. 2 to the 8th. Yeah, 2 to the 8th is 256, which means we only really need 8 brightness levels. So if we take this graph, this brightness graph, and then we take the natural log of it, I'm just using the natural log because I like it. You can really use any number you choose. You can use log base 2, log base 10, right? That gives us a very nice linear graph because humans are perceiving the same difference at every single step along the way. Same thing with volume. Volume should, I don't know about volume actually. But things like brightness for sure. And this is actually why the monitor jump is different. So this is kind of a different thing. Okay. So for monitors, let's say we have x squared. Let's say we're dealing with like square monitors for today, just for, you know, simplicity. If we have x plus a, we have 2 monitors. This one, terrible square. This one's x squared, and then this one is x plus a. Just do a square. And then this one's x plus a, and then this x plus a. That's on the inside x squared plus 2a x plus a squared. So, okay, a pattern I'm starting to notice here is it's kind of new minus old over old. This is the pattern I'm noticing. So here, this is new. If we subtracted the old, we had minus xi. We'd have the change in x over x initial, which would actually give us that 1 over x figure we talked about earlier. So here, the new is x squared plus 2ax plus a squared. So that minus x squared is just 2ax plus a squared. And then we'd have that over x squared. So if we wanted to take the integral of that, that would just be 2a, and then we have, oh no, we can't take that too. 2ax over x squared, which is essentially just 2a over x. So we have 2a times the natural log of x, plus the integral from 0 to t of a squared over x squared. Plus a squared, and then the integral, because that's a constant, we can just factor that out. X to the -2 dx, we get x to the 1 to the -1 over -1. Yeah, that makes complete sense. A squared negative x to the 1 over 1, so it's just -1 over x, aka 2a natural log x plus, not plus, minus a squared over x. So let's plot that out. So this green line shows us perceived monitor difference. So x is the initial size. A is the difference in size. So I don't know, I guess we could have it as a function of that. The hell? Okay, so if we start with start off with a 12.4 inch monitor. See, this one is weird. I guess the smallest monitor you'll have is about 10 inches. So if we That's so weird. No, don't like viewport, what the hell? So yeah, if you start off with, I guess the biggest difference you'll have in monitor size is like 30. But yeah, if you're starting off with like a 20-inch monitor, whoa, what the hell? I don't even know what I'm measuring here anymore, dude. I don't know, just shit should come with like exponents, bro. Like, humans perceive things in logarithmic scales a lot of the time. So, yeah. Anyway, I'm gonna dip out.